Hello students, today we discuss losses in DC machine. As we all know that energy neither can be created nor it can be destroyed. It can only transformed from one source, from one form to another form. So if we consider DC machine, in the section of DC machine, if we first consider DC generator, as per the property of the DC generator, it convert mechanical energy into electrical energy. So during this process, the entire input power is not transformed to the output section or output power. Some power is wasted in the machine itself, and the wasted power is known as loss. So these losses are categorized into four sections. In the first section, we are considering copper loss or the electrical losses in the DC machine, or it is also known as winding loss. Basically, this occur due to the winding resistance. So these are subcategorized into three parts. In the first section, we consider armature copper loss in DC machine. So let the armature resistance of the DC machine is RA and IA is the armature current. So due to this resistance, the power loss occurred inside the armature coil is I square RA, and that is 30% of the full load loss we consider. Next is field winding copper loss. Suppose RF is the field winding resistance and IF is the field winding current. So IF square RF is the field winding copper loss. Practically, the value of this field winding copper loss is constant, but theoretically it is considered 25% to the full load loss. And the third part is brush contact resistance loss in the DC machine. So this brush contact attributes or brush contact resistance drop is due to a resistance which is situated between the surface of the brush and the commutator, and due to this resistance a small amount of losses will occur, and this loss we are considering brush contact resistance loss. In the next category, we are consider core loss or magnetic loss. This loss occurs inside the magnetic circuit or magnetic part of the machine. So as basically the machine is rotating, so the magnetic field is rotating magnetic field we are getting. So due to this magnetic field, there are two losses occur inside the core and the armature winding of the machine, and that is hysteresis loss and eddy current loss. So first consider hysteresis loss. Hysteresis loss due to the hysteresis current of the machine of the armature winding. This loss will occur, and this loss is situated inside this loss we get inside the armature winding. And suppose the frequency of the magnetic reversal pole reversal, if the frequency we are considering that is f, then we know that f should be equals to pn by 120, and p is the number of pole where n is the speed of the machine, and there is a formula of hysteresis loss that we already know, that is p suffix h should be is equals to efficiency into the maximum flux density to the power 1.6 f and p, and the unit of this hysteresis loss should be watt, and P is represented by the volume of the armature, and the unit of this V should be meter cube. And in this magnetic core loss, the second part of this core loss is eddy current loss. As per the Faraday's law of electromagnetic induction, as we know that when the iron core rotates in the magnetic field, an EMF will induced in that core, and a small amount of EMF of this core will allows to flow a charge in the body due to this conductivity of the core, and this loss this current is basically useless, and this due to this current one loss will occur inside the core of the machine, and that is known as eddy current loss. Basically this loss can be optimized by lamination. If we laminate the core, then this core loss can be minimized. Next section or next category which I discussed today, that is mechanical loss. Mechanical loss occur due to the mechanical friction that is due to the mechanical friction of the moving parts of this machine. Basically, inside the bearing, brushes, as these parts are moving, so friction will occur into the moving part, and that's why a losses occur inside this moving part, and that is known as mechanical loss. There are there are other some losses also occur inside the DC machine, and these losses are very much small. We are considering this loss as stray loss. Stray loss, and basically the small losses we are considering, that is 1% of the full load loss. These are very this stray loss is very much small. So if we consider that, then P loss, then P loss is basically categorized into four part. One is copper loss, P copper. Another is core loss, P core, that is due to the magnetic part or magnetic circuit, core. Third part is mechanical loss, that is occur for the moving parts of the DC machine. And the last section is stray loss. That is a small loss, considering here consider the stray loss is 1% with respect to the full load loss. Again, the copper loss is subcategorized into the armature winding loss, field winding loss, and the third section is brush contact loss. And this core loss is eddy current and hysteresis loss, mechanical friction loss, and stray loss is the small amount of loss.